Let's first begin by looking at some background information. Here I will show you a short video of how the heart works. The three components of the heart is the heart, blood vessels, and the blood. The major functions of the cardiovascular system is to transport oxygen and nutrients to working muscles, remove byproducts such as CO2, lactic acid and toxins from your muscles. Another function is to fight off infections and to maintain the correct body temperature. Now let's look at the three types of blood vessels that are in your body. The first blood vessel shown in the picture is known as the artery. The artery carries blood away from the heart and is large, elastic and thick. Next vessel is the vein. The vein carries blood towards the heart and is thinner and less elastic than the artery. The next blood vessel is the capillaries. The capillaries are microscopic in size and they have extremely thin walls. The function of the capillaries is diffusion of gases to and from the cardiovascular system. The more you exercise, the more capillaries you create, which means you can get rid of more and more bad stuff in your cardiovascular system. There are four types of blood in the human body: red blood cells, white blood cells, platelets, and plasma. 45% of your blood is incorporated of solid sections, which is known as your red blood cells, white blood cells, and the platelets. The first blood type we're going to look at is red blood cells. Red blood cells carry O2 in the body and make up 90% of your blood. White blood cells and plasma are only a small part of your blood and they only make up 1% of the solid section. White blood cells are a vital part of the human body as they fight off diseases and infections. Platelets are the blood type that assist with the clogging of your blood. For example, if you cut your finger, look at it as if there was a hole in your finger. Your platelets will absorb that hole and stop the bleeding from occurring. That way your bleeding never goes on and on and on, or else you would bleed out. The final blood type, known as plasma, makes up 55% of the liquid section of the human body. It is clear, yellow, and it's 90% water and 7% protein.
Blood The pressure with which the blood flows in the blood vessels is called the blood pressure, usually called BP. Arteries receive blood from the heart, so blood pressure is higher in the arteries. The blood pressure gradually decreases as blood flows into capillaries. When this blood is collected into blood pressure is greatly reduced. So, blood pressure is less in the veins when compared to the arteries. Blood pressure is measured by doctors using an instrument called the sphygmomanometer. Blood pressure levels are written in the form of 120/8. This is normal blood pressure. The numerator 120 represents systolic pressure, and the denominator 80 represents diastolic pressure. During the systolic, when the ventricles contract, the blood is pumped into the arteries. So the blood pressure in the arteries increases immediately after the systolic. This rise in the blood pressure in the arteries is called the systolic pressure. When the diastolic occurs, more blood is pumped by the heart. The blood vessels return to the normal diameter and maintain blood pressure at a lower level. This is diastolic pressure. Hypertension or high blood pressure. In some people, the blood pressure will be very high, more than the usual 120/8. Such a condition is called hypertension, usually called high BP. One of the reasons for this is the blocking of arteries by cholesterol. Constant stretching and strain for a long time Improper functioning of kidneys, smoking, and alcohol consumption are also the reasons for hypertension. This condition, if not treated for a long time, may also lead to other health problems, and it may lead to the death of the person. Diet control, moderate exercise, and avoiding stress, smoking, and alcohol consumption, as well as taking appropriate medicine, will help to control.
About the size of your fist, the human heart is the most important muscle in the body. It can beat more than 100,000 times a day, pumping about 2,000 gallons of blood through a 60,000-mile network of vessels in the body. The human heart is made up of 4 major chambers: the right atrium, right ventricle, left atrium, and left ventricle. The right side of the heart receives blood that is low in oxygen from veins all over the body. It then pumps the blood through the pulmonary arteries into the lungs, where it will become reoxygenated. The left side of the heart receives this oxygen-rich blood from the lungs. Then it pumps the blood through the aorta back out to the rest of the body through a complex network of arteries, arterioles, and capillaries. While blood is circulating through the body, it delivers oxygen and nutrients to tissue through the capillaries, and at the same time picks up carbon dioxide and other waste material. The veins return the deoxygenated blood to the right atrium, and the cycle begins again. The heart has 4 valves. Each valve is like a one-way door that keeps the blood in the heart flowing in the same direction. The valves are made up of 2 or 3 small but strong flaps of tissue called leaflets. Leaflets open to allow blood to flow through the valve and close to prevent blood from flowing backward. The opening and closing of the valves is controlled by blood pressure changes within each heart chamber. The tricuspid valve is positioned in the heart's right side, between the right atrium and right ventricle. The pulmonic valve separates the right ventricle from the pulmonary artery. The mitral valve is positioned in the heart's left side, between the left atrium and the left ventricle. And the aortic valve separates the left ventricle from the aorta.
Now let's learn about what is meant by heart rate. Our heart rate is one of our vital signs. It determines how many times our heart beats or contracts per minute. A normal resting heart rate can be anywhere between 60 to 100 beats per minute. An active person or an athlete or an endurance trainer may find that their resting heart rate can be lower than this. There are many different ways to measure heart rate, one being you can measure it by either putting your 2 fingers on your wrist or your neck, as shown in the picture, or there is heart rate monitors that you can buy. There are many factors that can affect your heart rate, such as being exercise, body temperature, body position, whether you are standing up or sitting down, or your emotion, whether you are stressed or angry. A method used to find a rough calculation of your maximum heart rate, which means the maximum your heart can beat per minute when you are doing exercise, is 220 minus your age. The aim of the heart dissection was to widen our knowledge of the functions and the layout of the heart and explore how it works. Here's the list of the equipment used during the heart dissection. First things first, we obviously needed a sheep's heart in order to do the dissection. You also need a dissecting tray to place the heart on. You also need a scalpel in order to make the cuts in the heart. We also use what is known as a blunt metal probe, which we use to point to items and move different areas of the heart. We used a pair of surgical scissors to cut areas of the heart that we needed to for the dissection. We used tweezers in order to grasp onto items such as blood clots that were found in the heart. The safety precautions we took for this pack was wearing goggles, gloves and a lab coat.
Back of the heart. First, you need to identify where all of the vessels are. The front of the heart, usually you're going to kind of probe into there. This vessel at the top of the heart, it's actually the pulmonary artery. That's the pulmonary. And then directly behind it is the aorta. Or the aorta sits more towards the middle of the heart. And they kind of cross each other. So if I have both of my fingers in there, they kind of cross. Now this little branch of the aorta right there is called the brachiocephalic. On some of the hearts, if the aorta is cut too low, you don't see the brachiocephalic. But on this one, you see the three vessels on the top of the heart: the pulmonary artery, the aorta, and the brachiocephalic. On the back side of the heart, you should be able to find the opening here into the right side of the heart. Superior vena cava. And then on the other side of the heart, the opening is the pulmonary vein. We are going to make a cut in the heart. This model over here. Okay, so if we were to compare it to the model, there's the pulmonary. This is the pulmonary. There's the aorta. There's the aorta. There's the superior vena cava. There's the superior vena cava. We are going to make an attempt to cut the heart in the same way that this model is cut, so that the base of the heart pulls off like that. And to do that, the best utensil is a scalpel. And I'm going to position the scalpel up here and cut this way. The heart is a muscle, so you do have to actually put a little bit of work into the cut. And it's not entirely perfect. Here, look at the model. Open. Open. And then from the inside, you can see some of the structures. Again, orient yourself here. We have the front of the heart. So this is the left side of the heart, which would include the bicuspid or the mitral valve. There. The mitral valve is held in place by these strings called the chordae tendineae, which attach to a muscle there called the papillary muscles. The heart is divided into the left and right side via the side. And this side is, again, if we orient ourselves, this is the right side of the heart. So on this side we have, to cut it perfectly straight, we have the tricuspid. Also chordae tendineae attaching it. The tricuspid and the bicuspid are also both called atrioventricular valves. Now once the heart is cut, you can actually see the direction or the way the vessels enter each of the chambers. Right now I'm going through the pulmonary vessel, this way, and out it goes on the right side of the heart. Pulmonary vessel on the model, there it goes into the right side of the heart. If I do the aorta, I stick my finger in there, it crosses and goes into the left side of the heart. The left side of the heart is more muscular because it has to push all of the blood out the aorta, which is going to...
For the results, we have a blank diagram of the human heart labelled with the following structures: the left and right atrium, left and right ventricle, septum, aorta, the vena cavas, biscupid valve, triscupid valve, pulmonary artery and pulmonary vein. The diagram also displays the pulmonary and systematic circulation and the direction of blood flow. Now let's look at our practical findings and the discussion. Question number 1. What did you notice about the thickness of the muscle walls of the different sides of the sheep's heart you dissected? Answer. The left side of the heart is much stronger and thicker than the right, as it has to pump the blood to the entire body, so it needs to have plenty of strength in order to complete this. Question number 2. What is the role of the bicuspid and tricuspid valves? To ensure that blood flows in the right direction, there is one-way valves that exist. When the atria contracts, the valves open, but they close when the ventricles contract to prevent any backflow. The tricuspid valve is located on the right side of the heart between the right atrium and ventricle. It is made up of 3 flaps. The bicuspid valve is made up of 2 flaps and is located in the left ventricle and left atrium. Question 3. What is the role of pulmonary arteries and pulmonary veins? Arteries are vessels that carry blood away from the heart. The pulmonary artery transports blood from the heart to the rest of the body. Veins are vessels that bring blood to the heart. The pulmonary veins carry oxygenated blood from the lungs to the left atrium. Question number 4. What is stroke volume and cardiac output? Stroke volume is a calculation of how much blood is squeezed out of the heart into the aorta each time it beats. Cardiac output is the amount of blood pumped out of the heart per minute. There is a simple calculation to find out this amount. The immediate effects on stroke volume and cardiac output when you start exercising. As you begin exercising, your exercising muscles being used require more blood. Your stroke volume increases as a result of having to pump out more blood each heartbeat. Your cardiac output, which is the product of your stroke volume and heart rate, increases as your intensity increases. Method to figure out your maximum heart rate is 220 minus your age. What are the long-term training effects on stroke volume and cardiac output volumes after completing an endurance-based training program? A trained athlete will have a more efficient and stronger heart than an untrained person. In fact, an athlete's resting heart rate can be lower and can pump more blood with each beat, but does not need to pump as much per minute. In conclusion to the sheep's heart dissection, we expanded our knowledge and investigated the chambers of the heart. This resulted in a clearer understanding of the heart and its functions.
Let's start with atrium right. Carbon dioxide is high. Blood moves down to ventricle, pumping this blood to the lungs. Oxygen for blood. Onto the left atrium. All this blood has oxygen, moving in right from the lungs. Down to ventricle it pumps.